Okay, so we're back looking at another couple of examples, and there's a difference with this one. We don't have any powers, odd or even, but what we do have is the fact that our sine times our cos, the angles here are different in the sense that it's not both x or both 3x. And so that poses a bit of a problem. Okay, so what we need to do is, we notice here that we've got sine times cos. If we have a look at our formulas over here, we've got our multiple angle formulae, or if we have a look at the specialised information sheet, okay, this puts it a little better in that you'll notice, say we've got sine A times cos B, A and B representing different angles. Okay, that can be changed so that we can write it as a sum of those angles, but both using sine, or both so using cos depending on the situation. Now, clearly we've got sine times cos, okay, and the only one with sine times cos is this particular one here. Okay, so that's the one we're going to use. So let's consider that. If we have 2 times sine A cos B, then that can be written as sine A plus B plus sine A minus B. Now our particular situation that we have is that we've got 2 sine 3x cos x. So what can we write it then as? We can now write it as sine, our A is 3x, so that's 3x plus B, which is x, plus sine 3x minus x. Okay, so we have then, just simplifying that a little further, 2 sine 3x cos x equaling sine 4x plus sine 2x. And what we can do is, of course, if we just divide by 2, we can write that as a half on the right hand side. So now we can write our integral of sine 3x cos x dx would be the same as the integral of 1/2 sine 4x plus sine 2x. Okay, we take our half out the front. And now this is easy to integrate. Okay, we've got our half out the front. The integral of sine 4x is negative 1/4 cos 4x, and the integral of sine 2x will be minus 1/2 cos 2x. Okay, so then we can multiply throughout. So we'll have minus 1/8 cos 4x minus 1/4 cos 2x. Okay, so once we get it to this part here, it's straightforward if we know how to integrate these simple functions on their own. Okay, it's just being able to see what we can use. So become familiar with these different multiple angle products to sums formulas that we have. Okay, so let's scroll through and we'll do one more example of these type. And we'll do the integral this time involving tan power 5 of 3x times sec power 4 3x dx. Okay, this time we can use a substitution. Okay, we know that the derivative of tan is sec squared. Okay, so u equals tan 3x, which means du will be 3 sec squared 3x dx. Okay, so we can just do a few changes here, and we're going to change this into sec squared 3x times sec squared 3x, so that we can put our du here, but we need to have our 3 there, so we've got to put 1/3 out the front. So we've got tan power 5 of 3x times sec squared 3x times 3 sec squared 3x dx. So we can see that this part here will become our du. Now where to from here? If we go back and have a look, one of the modifications of the Pythagorean identity here is 1 plus tan squared a equals sec squared a. Okay, so what we can do is change this sec squared 3x to 1 plus tan squared 3x. Okay, so we've got 1/3 times the integral of tan power 5 3x times 1 plus tan squared 3x times 3 sec squared 3x dx. Okay, so it's working in a similar way to we did with the odd powers of sine and cos. Alright, so we've got 1/3 out the front here times the integral of, now we can do our substitution, okay, of tan 3x with u, so that's u to the power of 5 times 1 plus u squared du. Okay, so then 1/3 times after integrating, we have u to the power of 6 over 6 plus u to the power of 8 over 8, and plus our constant of integration. And now we can just expand throughout, of course, and we can replace u with tan 3x. So we'll have 1 over 18 of tan power of 6 3x plus 1 over 24 times tan to the power of 8 with 3x plus c, and that's our finished result. Okay, so where to from here? Well, there's some exercises that you can practice in the text. Okay, then we've got page, okay, so in the text we've got page 262, that's exercise 6C. So that'll give you some practice on integration that involves trig identities. Okay, so there's a good lot of problems in there that you can work through, and also in the Watson book there on is page 63. They are questions, or 62 rather. That's questions 38. The questions in 38. That's A through to N. Okay, so those problems will give you some practice integrating these types of problems. So you're getting a fair mix of integration problems between integration by parts, substitution, and partial fractions as well. Okay, and there's also another one which we need to look at as well, another method of integration that we will consider before going on to differential equations. So we'll leave it there.